We're going to unpack Earth's instruction manual. We'll explore exactly what we're riding on, how fast we're going, and the incredibly ingenious ways humanity has figured out how to measure and map the whole shebang. To kick things off, we've got to talk about the sheer, mind-boggling speed of our daily lives. Right now, you probably feel like you're sitting completely still, right? Well, you are absolutely not. At this very moment, the Earth is hurtling around the sun at a blistering 29.8 kilometers per second. Yeah, almost 30 kilometers every single second. Just let that sink in. Every time a second ticks by, you, me, and literally everything we know has traveled another 30 kilometers through space. It's a wildly dynamic, high-speed ride. And to figure out how to navigate it, we need to establish some ground rules for how we actually study it.
Section 1. The language of geography, finding our lenses. So, to really comprehend this speeding rock, we have to look through specific scientific lenses. And for that, we owe a massive debt to the ancient Greeks. They were actually the very first people to formally study geography. They basically handed us the vocabulary and the frameworks that we still use today to make sense of our world. Let's check out 3 of the most important lenses they helped inspire. Our first lens is geopolitics. Now, this is all about how surface-level factors directly dictate human power and global relationships. It's the study of how geographical factors, things like a country's physical location, its rugged terrain, or its access to natural resources, how all of that heavily influences international politics. This lens is a great reminder that geography isn't just about figuring out where things are on a map, it's about how those physical placements literally shape the rise and fall of nations. Okay, moving on to our second lens, geodesy. Now, while geopolitics looks at human power, geodesy is entirely focused on the physical stuff. It's the precise scientific study of the Earth's literal shape, its exact size, and its dimensions. Without geodesy, well, we wouldn't have GPS, we wouldn't have accurate maps, and we really wouldn't have any true understanding of the physical scale of our planet. It is, quite literally, the math behind the map.
And that brings us right to our third lens, geology. The word itself is pulled straight from the Greek, geo, meaning earth, and logos, meaning study. Geology examines our planet from the inside out. It looks at internal processes like the churning of magma and the shifting of those massive tectonic plates. But it also looks at the outside, external processes like weathering, erosion, and sedimentation that carve out the landscapes we see every day. Geologists study fossils, natural hazards, and vital resources like coal, oil, and water. Oh, and here's a fun fact about Earth's history. The very first study on the different historical eras, or epochs, of the Earth was actually conducted by a scientist named Buffon.
Section 2. Our speeding, bulging planet, busting the round Earth myth. Okay, so we already know we're flying through space at almost 30 kilometers a second. But how big is this ship we're on? Well, the circumference, meaning the distance all the way around the equator, is roughly 40,000 kilometers. But the actual shape of that 40,000-kilometer rock? That might actually surprise you.
We've got to do a little historical myth-busting here. So the legendary ancient philosopher Aristotle famously believed that the Earth was a perfectly round sphere. And honestly, for a long time, that was just the standard belief. But modern reality and that advanced geodesy we just talked about tell a completely different story. The true shape of the Earth is actually called a geoid. A geoid is an imperfect, bulged sphere. So no, it's not perfectly round at all. Because the Earth is spinning so incredibly fast, it actually squashes down at the top and bottom poles and bulges out right at the middle.
Let's actually look at the exact numbers behind that bulge. The equatorial diameter, which is the width of the Earth straight across the middle, is 12,756 kilometers. But the polar diameter, so the height from the very top of the North Pole down to the bottom of the South Pole, is only 12,714 kilometers. Do the math, and that means the Earth is actually 42 kilometers wider across its middle than it is tall. Aristotle was a brilliant guy for sure, but he definitely missed that 42-kilometer bulge.
Section 3. Drawing the lines, latitude, the invisible grid. So, how exactly do we map this massive, bulging geoid? Well, let's focus on the horizontal lines.
Just think about the sheer precision of this grid. Latitude measures your exact distance north or south of the equator. Imagine starting at 0 degrees right in the middle of the planet and climbing step by step up to 90 degrees at the North Pole or down to 90 degrees at the South Pole. We call these steps parallels because they're imaginary horizontal circles drawn completely parallel to the equator. And here's a totally mind-blowing mathematical fact. If Aristotle had been right and the Earth was a perfect sphere, every single one of those degree steps would be exactly 111 kilometers apart. To cover the entire planet, we draw 179 lines of latitude at 1 degree intervals. So that's 89 lines in the northern hemisphere, 89 lines in the southern hemisphere, plus that one crucial equator line tying the whole thing together.
Section 4. Life on the equator, the center of the map. Let's zoom all the way in on that vital 0-degree mark. Literally everything we map north or south depends entirely on this specific invisible belt that wraps around the absolute widest part of our planet's bulge.
Now, given how massive the Earth is, you'd probably think the equator passes through a huge portion of the world's nations, right? Well, actually, out of the entire massive surface of the globe, the equator is incredibly exclusive. It directly crosses through only 13 countries. If you ever want to stand perfectly at 0 degrees latitude, you really have a very limited list of national borders to choose from.
But, hey, even though that country count is surprisingly small, the geographical scale of the equator is still absolutely epic. This singular imaginary line spans the globe by slicing completely across 3 distinct continents: South America, Africa, and the Asia and Oceania region. On top of that, it stretches across the vast expanses of 3 major oceans: the Atlantic, the Pacific, and the Indian Oceans. It really is the ultimate geographic connector.
So, we've definitely covered a lot of ground today. Knowing what you know now, that you are currently standing on an imperfect, bulging geoid that's flying through the vacuum of space at almost 30 kilometers every single second and is entirely wrapped in an invisible mathematical grid of 17 precise lines, how does that change how you look at a simple map? The next time you look up a location on your phone or spin a globe, I want you to remember the geology, the geodesy.